I invented a heat exchanger that recovers half of the energy that goes down the shower stall drain. The recovered energy is transferred to the incoming cold water. When the draining warm water gets to the heat exchanger, a rotary sweep washes that water against the copper coils. The cold water going to the shower powers the rotary sweep. That cold water spins an impeller with magnets. The impeller turns at about 200 RPM. And because it's magnetically coupled to the drive gear, it also turns at 200 RPM. The speed reduction gears reduce the rotary impeller to about 30 RPM. The heat exchanger goes where the drain would normally be, and it has a large circular cover. The warm gray water drains through an outer ring of slots onto the warming coil below. Then the rotary sweep pushes the water around a circular path toward the drain. The floor of a shower stall is really a big funnel that gathers up all the warm gray water and routes to the drain very quickly. That is unfortunate because it doesn't have time to give up its heat. In my heat exchanger, the water takes a 70-foot journey with the assistance of the rotary sweep to the drain. Now it has time to give up its heat, and the rotary sweep improves the transfer by washing the copper coil with warm water. Preheating the cold water reduces your energy use by a factor of 2. This figure shows the overall system. The heat exchanger fits in the same location as the drain, with the exception of the cold water making a detour to the heat exchanger. There is no change in plumbing. This figure shows my heat transfer calculations. The gray water and cold water flow in opposite directions. The gray water has a larger flow rate and cools a little less than the incoming water heats up. The temperature difference between the gray and cold water is 10 degrees. The water velocity and heat transfer area inside and outside the tube are about the same. So ignoring the temperature drop in the copper tube wall, there is probably a 5-degree drop on either side. As shown in this video, I have already built a model of the heat exchanger. My next step is to build a metal one and measure the heat transfer and pressure drops.